Hello, are you ready to ramble? Let's go. We are looking at the department's grade 12 maths paper 1 of May 2023. And we're looking at question 5 today, so let's get it. The graphs of the functions f of x is equal to negative x plus 3 squared plus 4, so that's a parabola with a turning point of negative 3 and 4, and it's a downward facing parabola, as you can see on the diagram as well. Okay, cool. And then g of x is equal to x plus 5, so that's a straight line. Gradient 1, y-intercept 0, 5. Cool. They're drawn below, and the graphs intersect at a and b. Lovely. Write down the coordinates of the turning point of f. Okay, so they've very graciously given us the equation of the parabola in turning point form. So that tells us that the turning point is going to be negative 3 and 4. Write down the range of f, so the y values, the set of y values that this function produces. So we can see that our graph peaks over there, so that's as high as the y values get. So the range of f is f of x does not go beyond 4. So f of x is smaller than or equal to 4. And I think this implies we're talking about real numbers, but just to be safe, you could indicate that, we are definitely talking about real numbers. Okay, I'm also just going to fill in our turning point over there. You don't know when you're going to need it. You just don't know. Right. Okay, and then show that the x coordinates of a and b are negative 5 and negative 2 respectively. So a and b are our points of intersection between the two graphs, so we can figure out what the x coordinates of those points of intersection are by equating f's expression to g's expression. So let's go ahead and do that. So we've got negative x plus 3 squared plus 4 is equal to x plus 5. So just going to expand this guy. Okay, quadratic equation, so I'm going to gather all my terms on one side. So minus 6x minus 7 minus x, sorry, is minus 7x. Minus 9 plus 4 is minus 5. Minus another 5. Okay, if we minus 5 on both sides, so that'll be negative 10. And I'm just going to divide through by negative 1 to get rid of this negative coefficient. So we've got x squared plus 7x plus 10 is equal to 0. This is looking nice and factorizable. And I mean, we get a hint there that it can in fact be factorized. So x is equal to negative 5 or x is equal to negative 2. Right, and so therefore the x-coordinate of a, seeing as that appears earlier on the x-axis, is the smaller one, negative 5, and the x-coordinate of b is going to be the larger one, negative 2. Okay, right. And then the next question, I think I'm going to go to the next page for that one. So let's just quickly duplicate the page. Okay, right. So, next question says, hence Determine the values of c for which the equation negative x plus c plus 3 squared plus 4 is equal to x plus c plus 5 has one negative and one positive root. Okay, so in English, what is happening here is, right, we know that if we have a function and we add something, we add a number to the x, to the input, if this c is positive, then our graph moves to the left, right? Our graph moves, how do I write this? Graph moves left, right? And if c is negative, then our graph moves to the right. And if you'd like me to do an explainer video to talk about why that is, I would gladly do that. You must just ask. But yeah, no, seriously, if you're interested to understand why that is, I absolutely love explaining that, especially because it took me a second to figure out. Yeah, it was very unintuitive at first. Anyway, also, even better, if you have a nice, neat way of explaining why this is, share in the comments, describe in the comments. Okay, anyway, right. Back to my point. So we can see here on the left, this is the same as f of x plus c. And on the right, we've got g of x plus c as well, right? So what this question is asking us, oh, do I want to erase that? I don't think I did. Let's just shrink and relocate. Okay, so, okay, wow, drama. Ooh, oh, okay, cool. Right, so that's what we've got on the left. This is what this equation pretty much is. So let me just highlight it and say it is the same as that, right? So we are being asked for which values of c will this parabola shifted by c units and the straight line shifted also by c units. So pretty much we're taking this whole unit and we're either moving it to the right or we're moving it to the left, right? And what we're interested in is how much do we need to move it by in order for the x coordinate of a to be negative and the x coordinate of b to be positive. Right now they're both negative. Okay, so if we move this little setup to the left, right, a and b are just, well, okay, I'm saying a and b, the x coordinates of a and b are just going to be negative, right? Like there's no way they're going to become positive if we keep dragging this thing more and more to the left. So c can't be a number that moves the graphs to the left. Okay, so the only option is for us to move to the right. Okay, so now let's see what happens when we move it to the right. So there's a certain number of units. So right now the x coordinate of b, actually let's just write this down. The x coordinate of a is -5. Okay, and we don't know what the y is. I mean, we could figure it out, but we don't care. And the x coordinate of b is, again, it doesn't look like we're going to need this turning point, so I'm just going to rub that out for now. Okay, the x coordinate of b is -2, right? Okay, right. So if we move our setup 2 units to the right, then b is going to be on the y-axis, okay? And a will still, well, the x coordinate of a will still be negative, it will be -3. Okay, so that isn't quite what we want. We want one of them to have a negative x coordinate and the other one to have a positive x coordinate. So if we move the setup by anything more than 2 units to the right, then B is going to start showing up over here, and A is going to hop along over here, right? But if we just keep moving them indefinitely to the right, there's going to come a point where the parabolas over here and the straight lines over here, and terrible diagram, and the x-coordinate of A will also now be positive, right? Which is not what we want. We want A to have a negative x-coordinate and B to have a positive x-coordinate. So there's a closed range. It's not an open-ended range for C, right? We've seen that if we move the setup by 2 units to the right, then that takes B to the y-axis, and then if we just inch it a little bit more to the right, from there B has a positive x-coordinate and A has a negative x-coordinate. So now we're in the sweet spot. But then we want to make sure that A does not get past here, right? We don't want A to now have an x-coordinate that's bigger than 0. So that happens when we've moved the setup by 5 units. Once we've moved this by 5 units, then A ends up over here, and anything more than 5 units is going to take A into the positives. Okay, so that kind of gives us our answer. We want to move right by more than 2 units, okay, but also it has to be less than 5 units, because if it's now more than 5 units, then A is going to end up on the positive side of the x-axis. Okay, so how do we write this mathematically? So we know that if C is positive, then our graph moves to the left, which is not what we want. C is negative, then our graph moves to the right. So we want our C to be between -5 and -2. So it must be bigger than -5, and it must be smaller than -2. So then we get things like -3, -4, and so on. Okay, I don't know why I felt the need to mention that, but yes, this is how we translate this expression into the mathematics. Okay, and why not equal to? Not equal to because remember, if we move by 2 units, then B ends up on the y-axis, aka its x-coordinate is 0. So it isn't positive, it isn't negative. So that's not what we want. And likewise, if we move it by exactly 5 units to the right, then A is going to end up here on the origin. So its x-coordinate is 0. Again, neither positive nor negative. And the question wants us to have one negative, one positive root. Okay, so that is that on that. I think I might need a new page for the next question, so let's quickly do that. Okay, right. So the last question says the maximum distance between F and G in the interval where X is between A and B. That's a terrible way to say it, but okay. Between A and B is K. Okay, so let's just say, for instance, the maximum distance is somewhere here, right? We're being told that that distance is K units. Okay, right? So if h of x is equal to g of x plus k, okay, so the straight line, if the straight line is moved up by k units, determine the equation of h in the form h of x is equal to dot dot dot. Okay, so the question is then, where does the maximum distance between f and g occur, right? So what is the x coordinate here? What is the x value here for when that maximum distance occurs? Because then we can figure out what k is. So if we then find that k is 10 units, then we know that the equation of h is just going to be the equation of this line bumped up by 10 units. Okay, so we don't even need the x. Okay, we need the x in order to find what the maximum distance is. Okay, cool. So let's do it. So we can see that in this interval between xa and xb, the graph that is producing bigger y values is f, right? F is above the straight line. So we are going to figure out what is f, an expression for f minus g. So that is going to be minus x plus 3 squared plus 4. I was wondering why I didn't have space. Okay, now all of a sudden things are ginormous. Okay, let's try that again. Right, and we're subtracting x minus 5, so that is, okay, we actually have this from the previous question, so that ended up being this. Okay, so that is negative x squared minus 7x, yeah, minus x squared minus 6x minus x is minus 7x, minus 9 plus 4 is minus 5, plus 5 is 0. So the expression for the distance between f and g in this little interval is given by minus x squared minus 7x. Okay, so now the question is, at what point is this expression at its maximum? So which value of x maximizes this expression? And we can find that by differentiating, right? So and the first derivative here is negative 2x minus 7, right? And we find the place where this is maximized by equating that first derivative to 0, and we solve, and we find that, okay, the maximum of this expression is occurring is occurring when x is equal to negative 7 over 2. Okay, so negative 7 over 2, negative 3.5. So right, that is where we have the biggest difference between these two graphs, the biggest distance between these two graphs. Okay, so now we know that it happens when x is equal to negative 7 over 2. Let's then see what the k is. So to find that distance, so k is equal to negative, right? So we're putting it back into this expression, the expression for the difference between the graphs, the distance between the graphs. Okay, I do not feel like working that out manually, so I'm just going to invoke my friend. Right, so that distance is 49 over 4. Okay. Okay, so now we know that the maximum distance between f and g in this interval is 49 over 4. Okay, so k is 49 over 4. So if h of x is equal to g of x plus k, what is the equation of h of x? Well, it'll just be g of x plus 49 over 4, which is x minus 5 plus 49 over 4. And I think that that comes to x plus 29 over 4. Okay, so let's hear what the memo has to say about all of this. So, for the first question, if I can just find the memo. I cannot find the memo. The memo is not open. Oh dear. Okay, so we are on question 5. So for the first question, I should probably have been checking them as I went along, right? For the first question, we have turning point -3 and 4. For the second question, we have y is less than or equal to 4. Perfect. For the third question, we have, well, yeah, we managed to show that x is equal to -5 or x is equal to -2. That was given to us. Right. And then the fourth question, we have c must be between -5 and -2. Awesome. And then for the last question, we have h of x is equal to x plus 7¼ Yes, 7¼ is the same as 29 over 4. Awesome. Yes. Great. Lovely. Cool.